All right, hi everybody. Okay, so we're going to be looking at about two things today. First thing we're going to look at is continuing to evaluate polynomial functions, and then after that we'll move on to some intro to graphing the polynomial functions. So first thing, all we're doing is evaluating, so that just means plug in. Example 1, we just want to find f of negative 3, and then we're given the function f of x equals this 3x to the 8th, down the line, all of that stuff. And so we just need to plug in, so let's go ahead and do that. So what do we got? We got f of negative 3 equals 3, and then there's an x, so we're going to put a negative 3 there, to the 8th power minus 7, negative 3 again, this time to the 5th power, minus 13, negative 3 to the 10th power, minus 20, negative 3 to the 3rd power. Okay, and so all we need to do here is evaluate our exponents. We'll do our exponents first because we've got to do order of operations, right? PEMDAS. Got to follow that, PEMDAS. So I'll do all my exponents first. So negative 3 to the 8th should have 6,561 minus the 7. Then we have negative 3 to the 5th. That's negative 243 minus 13. 243 minus 13, negative 3 to the 10th, 49,049 minus 20, and negative 3 to the 3rd, negative 27. Okay, so notice that where we have positive exponents, where we have even exponents, we got a positive number. All right. So now we're going to multiply. 3 times 6,561, 19,683. We have a double negative, so that's going to be a plus here. 7 times 243, 1701. 13 times 59, 0. 49 minus 767,637, 20 times 7. Double negative again makes a positive 540. And then just go ahead and use your calculator one more time to add all those up. 196,883 plus 1, minus 767,637 plus 540. Should get a negative 745,715. Okay, so just plugging it in. First you do your exponents, and then you do your multiplying, and then you add them up, just like we did. Okay, so now we're going to do example number 2. This one's a little bit more complicated. We have find 4f to the 4th minus f squared to the 3rd. And so we're just going to go ahead and write exactly what it says there. So we're going to start with a 4, and then we need f with 5 plugged into it. So I'm going to put a big parentheses here, x to the 3rd, so we have a 5 to the 3rd, and then minus a 5 to the 2nd. And so if you look, here's 4, here's f. 4f, here's 4f. So what do we have? Then we have another f. This f is squared, so we'll do the inside first. 5 to the 3rd minus 5 to the 2nd, and square that all at the end. So here we have minus f squared minus, here's f squared. Oh, but they did want us to plug in 3 on the 2nd. We're not plugging in 5. There's a 3 in the parentheses for the second f, and so in the second f we put 3's. Okay. So order of operations, we need to do what's in the parentheses first. So let's go ahead and do that. So we'll leave the 4 right where it is, and then go all the way to the inside of the parentheses. 5 to the 3rd is 125 minus 5 squared. 5 squared is 25 minus, and then big parentheses. 3 to the 3rd is 27 minus 3 squared is 9. That's squared. Do what's in the parentheses again. Work your way from the inside out. So 125 minus 25 is 100. And then we have minus 27 minus 9 is 18. have to square that. So at the end, that's 400. 4 times 100 is 400, and then 8 minus 18 squared is 324. Subtract 76 is our answer. Okay, so all we had to do here was read what's up there and then plug in the numbers that they told us. And now what we're going to do is we're going to keep doing that, except instead of plugging in 5, 3, or another number, what we're going to be plugging in is a different expression. So in the x, instead of having just a number, we'll have, there might be numbers there, but there's also going to be letters, and we'll have to swap out the letters as well. So let's go ahead and do that. And I'm going to leave PEMDAS up there, so we still have to follow PEMDAS. Does not change. Okay, so now what we're going to do is we're going to keep evaluating, so that means we're just going to continue to keep plugging things in. What gets a little bit more complicated now is instead of plugging in a number, just a number like 3 or 5, we'll actually be plugging in a small expression. So let's take a look at how that works. Now, this example, number 3, wants us to find g of 3a if g of x is 2x to the third minus 5x minus 4. Okay, so let's, wherever x is, what did we do before? We took a number and we plugged it in where x goes. And where did we get that number? From in these parentheses. So that's exactly what we're going to do. We're going to take what's in these parentheses and just plug it in where x is. So let's go ahead and do that. G of 3a is equal to 2. Here's where x is, so we're going to put a 3a there to the third minus 5. Put a 3a where the x goes, minus 4. All I did was, wherever an x is, I put a 3a there. And so now we need to do some simplifying. Got to make sure that we do our exponents before we multiply, so the 2 stays in the front. And this should be a 3 to the third, and then an a to the third. You have to distribute that exponent, and then minus, and then we can just multiply here. 5 times 3 is 15a. There's no exponent there. Minus 4. Almost done. Equals. Again, we need to do exponents before we can multiply. So 3 to the third, that is 27. A to the third follows it. Minus 15a. Minus 4. Last step, multiply 2 times 27. 54a to the third minus 15a minus 4. And there is our answer right there. Okay. So we're going to step it up a little bit. Now there's going to be 2 things done to the function. So this time we had an input for the function. Here we're going to have an input again, but we also have this 8 in the front. And so that means that you have to take the entire function h and multiply. So we've got this negative 2b that we need to plug in, but there's also this 8 out in front. So I'm going to copy this exactly how it is. I'm going to do the 8, and then I'm going to put h. So we need a 8h, negative 2b, equals, here we go, 8, and then we need to put h. So 9, and then x changes into a negative 2b, that's to the fourth, plus 4, negative 2b where x goes again, to the third, minus negative 2b. Okay, so here you go again. 8 times h. 8 times h, and we plugged in negative 2b. So, parentheses first, PEMDAS. So we got to leave the 8 there in the front. And we got the 9, because then we have more parentheses there. So we have negative 2 to the fourth, and then b to the fourth, plus 4, negative 2 to the third, b to the third, and then no exponent here, so go ahead and multiply a negative and a negative makes a positive 2b. Okay, so now we have some more exponents to do, so we'll do that. We still have an 8 in front, and then we still have a 9. Negative 2 to the fourth is 16. So we have 16 still with a b to the fourth, plus 4. Negative 2 to the third is negative 8. And then we got b to the third, and then plus 2b. Okay. Now we're going to multiply the stuff on the inside of the parentheses. 9 times 16 is 144, so we have 144b to the fourth. 4 times negative 8 is a negative 32 with a b to the third, and then at the end plus 2b. And there we go, this is the last step. Now distribute the 8 to everything. So 144 times 8 is 1152. And then we got the b to the fourth. Minus 32 times 8, which is 256. So minus 256 with b to the third. And then plus 2 times 8 is 16b. So here's your answer there. Right? So just still doing the same thing, just plugging in, and then we had this 8 in front of h that we had to keep there in front of h the whole time. 2 more examples to do. Get a little bit harder. Okay. All the time we have to be following PEMDAS. All the time. Start with the parentheses that are the most on the inside, and then work your way out. Okay, so example 5, this time I want to find f of 2m minus 4. So f of 2m minus 4. And then we have f of x, and here's our function, x to the third minus 5x plus 7. Okay, so even though there's a 2m and then a minus 4, all of this on the inside now, you take all of that and plug it in where x goes. So we have x to the third, so that's going to be 2m minus 4 to the third minus 5, and then we have 2m minus 4 where x goes plus 7. We do have a little bit of multiplying to do over here, so I'm going to do 2 of these at a time. We have 2m minus 4 and then 2m minus 4 and 2m minus 4, because there's 3 of them. Minus, and we can go ahead and multiply this right now. 5 times 2m is 10m. Negative 5 times negative 4 is a plus 20, and then we still have the plus 7 there at the end. Okay, so now we have a lot of multiplying to do over here. Let's start with the first 2. Multiply distribute the 2m. So we got 2m times 2m is 4m squared. 2m times negative 4 is negative 8m. Now distribute the negative 4, and we got negative 8m again, and then negative 4 times negative 4 is a positive 16. So we've done the first 2. We still have to do the third one. We haven't done that yet. And the minus 10m at the end, we have 20 plus 7, and that makes a 27. Okay, a little bit more multiplying to do. And so what do we need to do? Let's simplify this first, because it'll make first a little bit less multiplying. We're going to have to distribute this again, and if we have one less thing over here to distribute to, that's one less thing to multiply. So 4m squared, now a minus 16m plus 16, then 2m minus 4 minus 10m plus 27. So the only thing that changes is I combine some point terms right there. Okay, same thing, distribute the 2m. And so then 2m times 4m squared, 8m to the third, 2m and negative 16m, make negative 32m squared, 2m and the 16, that makes 32 just with one m this time. Okay, and then just like we did before, I got to distribute the 2m and distribute the negative 4. So let's do that. Negative 4 move over there, times 4m squared, that's negative 16m squared. Negative 4 times negative 16 is 64 with an m, and then negative 4 times a positive 16 is a negative 64. Okay, so we have all of that stuff from the multiplying, and then just these little 2 guys here at the end, negative 10m plus 27. So we'll combine just a couple like terms here. Like terms that we have are the 10m and the 64m, and then we also have the 27 and the negative 64. Everything else will just stay. Oh, we also have the negative 16m squared and the negative 32m squared, so we do have a little bit more. And we also have these m's that can go with these. Okay, so 8m to the third, negative 32m squared and negative 16m squared make a negative 48m squared. Okay, so we combined all our m squareds, combined all of our m's, negative 32, positive 64, and a negative 10. That would make a 32, and so minus 22m. And combine our constants, things without m's, negative 64 and a positive 27 make a negative 37. And here's our answer. All right, so we have one more to do. This one's going to be the most complicated. We won't see a whole lot of these, but we want to be able to put all this stuff together. So, give myself some room here by erasing this. Okay, so we have 2f, and then inside of f, 3p plus 4 minus g. We got to square that, and we're going to plug in a p squared to it. And we have our two functions. So first we have 2, and then we need f. F is right here, x squared minus x. So put those in parentheses. So for the x squared, what's got to go in there? 3p plus 4. Then minus, and we got to square that because there's a square there, minus 3p plus 4. So far, 2f, 2f, and I plugged in 3p plus 4 where the x's are. Okay, then we have minus, and then we need g. G is x to the 5th minus 3x squared, and we have to plug p squared into that. So we have p squared to the 5th minus 3 p squared squared. Ooh. Yeah. Yep. There's all of g, and we got to square all of g. Okay, so we already talked about the f minus. Here's g squared. G squared. Here's g squared, and we plugged in where x is. We plugged in p squared because that's what's in the parentheses. Over here. Okay, so let's get to work here. So in here we need to go parentheses first, PEMDAS. So we have 2, and then we need to do 3p plus 4. 3p plus 4. Squared means to multiply by itself. 3p plus 4. And once we're done with that, subtract a 3p plus 4 minus. And now we deal with the inside of g. P squared to the 5th is a p to the 10th minus 3p p squared squared. Multiply those. 2 times 2 is 4 for the exponent. And then we have to square all of that. Okay. Dig in a little bit more on the f on the inside of the f function. 2. So we're going to distribute now. 3p times 3p is 9p. 3p times 4 is, well, that's a 9p squared. No, p times p, that's a p squared, so 3p times 4 is 12p. Again, 4 times 3p is another 12p. And 4 times 4 is 16. And then after all of that, we still have minus 3p plus 4 from right here. Okay. Dealt with the inside of the f function a little bit. Now we need to look at the g function again. So we need to square this. We have p to the 10th minus 3p to the 4th times p to the 10th minus 3p to the 4th. Okay. You can simplify on the inside a little bit over here. Just deal with like terms. It was 2. We only have p squared once, so there's 9p squared. We have a just regular p's. We have a 12p, a 12p minus 3p. That's 24 minus 3 is plus 21p. 16 and 4 add up to 20. Okay. Over here with the g, we need to distribute. We have this thing times this thing, so we got to distribute. P to the 10th times p to the 10th is p to the 20th. P to the 10th times negative 3p to the 4th, negative 3p to the 14th. Do the same thing here. Negative 3p to the 4th times p to the 10th. Another negative 3p to the 14th. And then at the end, negative 3p to the fourth times another negative 3p to the fourth. Positive 9, negative and negative 3's make 9. P, 4 and 4 add up to 8. Okay. 2 steps left. First, we need to multiply the 2 over here. We need to distribute the 2 now that everything on the inside has been dealt with. So 2 times 9, that's 18p squared. 2 times 21 is 42p. 2 times the 20 is 40. Minus, and I don't think, oh, we have one like term with the 3's here. So we'll do that. P to the 20th, that's negative 6p total. 14 plus 9p to the 8th. And the very last step is just to distribute this negative. It was 18p squared plus 42p plus 40 minus p to the 20th plus 6p to the 14th minus 9p to the 8th. And there's your answer. Okay. So right now what you should do is you should pause the video, because the next one you need to try on your own, and once you've tried it, then the answer will pop up here on the video when you press play again. So do that now. Okay, so here on the one that you were supposed to try, here's what we had. We had 5f, and then inside of f we needed to plug in 4k minus 3, so that's what I did. Here's 5, here's f, 5f, 5f, and wherever x was, I put a 4k minus 3. There's x squared, there's 4k minus 3 squared. And then after that, so I separated the squared here so that I can easily distribute, and I also distributed the negative 7 right here. Then from there to the next step, I distributed here with the multiplying 4k minus 3 times the 4k minus 3, did all my distributing. I was also able to combine 21 minus 20 into a 1. Then after I did that, I had some k's that I was able to combine, negative 12, and negative 28 to make negative 52 here. Combined all my k's, and then this is all simplified now. So at the very end, took my 5 and multiplied it inside and distributed. And so we should end up with 80k squared minus 260k plus 50. Okay. So now the next. That's all we have for the notes of evaluating polynomials. Now we're going to move on to the graphing. A little bit of straightforward notes here, a little bit of guided notes, and then we'll see how this all ties together. Okay. So intro to polynomial graphs. A couple reminders here. The degree of a polynomial is the same as the greatest exponent. So whatever your biggest exponent is, that's your degree. Okay. So the degree also tells us something else. It also tells us the maximum number of times that the graph can cross the x-axis. Cross the x-axis. So maximum, of course, means that it may cross less than that, but because it's a maximum, it cannot cross more than that. Okay. Keep it going. So a polynomial degree 8, or cross the axis, cross the x-axis 8 times or less. And we should be able to guess what the answer to the next one is going to be. A polynomial of degree 5 will cross the x-axis 5 times or less. This is the degree, that's the maximum number of times that we can cross the x-axis. When the graph crosses the x-axis, the crossing spot, we call that an x-intercept. Cross the x-axis, that's called an x-intercept. Or another name for that is a 0. Because at that point, y is 0, so that means if you take the x number from the x-intercept and plug it into the function, you will get 0, which is why we call it a 0. But you have to plug it in to get that 0. Okay, so let's move on. What we're going to do now is start talking about the end behavior of these polynomial functions. So the end behavior is not really too complicated. End behavior, it's all about what is the graph doing on each end. What is the graph doing on each end? And that does depend on if your polynomial has an even degree or an odd degree. If your polynomial has an even degree, the ends will point the same way. Ends point the same direction. So they're either both up or both down. Every time for an even degree, that'll happen. For an odd degree, the ends point in opposite directions. Okay, so you'll have one end will go up and the other end will go down. Okay? So what does that look like? And we see that each one of these sides, even degree has 2 more boxes, odd degree has 2 more boxes, because there is a little bit, once you split it once, it does split again. And what it depends on is it depends on the sign of your leading coefficient. So for an even degree, if we have a positive leading coefficient, then your graph will look something like this. So there's your graph, even degree. So if we have a positive leading coefficient, it's going to come from above. So maybe it comes down and does something like this. Okay, so this would be an example of an even degree with a positive leading coefficient. Both ends are going to go up. And so the way we would describe that in math terms is that as x goes out to negative infinity, so on the left side, on the negative end, what's happening to f of x? F of x, on the left side, f of x is going up and up forever. That's what this arrow means, so that it keeps going up and up forever. Since it's going up, that's the positive direction, so that means that it's going towards positive infinity. Okay? So what's the other end doing? This is the left side, the negative side. What's the positive side doing? So we're talking about what's happening as x goes to positive infinity. So on the positive side, if I keep going to the right, what's going to happen? And so we can see right here that on the right side, it's also going up. It's going up and up and up forever. And so that means that just like the left side, f of x is going to positive infinity. So let's take a quick second. X going to negative infinity. That's the left or negative side of the graph. As x goes to positive infinity, that's the right or positive side of the graph. Okay. Notice this follows exactly what I said. It's an even degree, and both ends go in the same direction. Those are both going up. So I'm sure we can kind of figure out what's going to happen if our leading coefficient is negative. So a negative leading coefficient is going to look something kind of more like this. It's going to come up from the bottom. Maybe do something like that. Okay, and so this is what that's going to look like. Oh, nope, sorry. Maybe do something more like that. Okay, so it's going down on both sides. So as x approaches negative infinity, so on the left side of the graph, what is it doing? F of x, the graph is going down and down and down forever and ever, so the graph is going to negative infinity on the left side. Okay, so what's it doing on the right side? So on the right side, the positive side, that's x going towards positive infinity. And if we look on the right side, it's going down and down and down forever. And so f of x, since it's going down, that's negative, and it's going to negative infinity. Okay, so that is what everything looks like for an even degree polynomial. Now let's take a look at the odd degree polynomial, and it's going to split exactly the same. Positive leading coefficient, negative leading coefficient. So if we have a positive leading coefficient, then what is that going to look like? So now one end should be up, one end should be down. If we have a positive leading coefficient, then the negative side will come from the negatives. So it'll look something like this. And the positive side will go up to more positive. So something like that. So we got on the left, we're coming from the bottom. On the right side, it's going up and up forever. So let's write that out in our math language. So on the left side, that's as x goes to negative infinity. That's the left or negative side. What is the graph doing? The graph is going down and down and down forever. Down is negative. So f of x also going to negative infinity. Okay, so we talked about the left side. Now let's talk about the right side. On the right side, that's the positive side. So as x goes to positive infinity, what is the graph doing? It's going up, and it's going to keep going up and up forever. So on the right side, f of x, the graph is going towards positive infinity. Notice that for the odd degree, the signs match. As x goes to negative, f of x goes to negative. And when we have a positive leading coefficient, let's see if that happens again with the negative leading coefficient. So the negative leading coefficient, we might have a graph that looks something like this. It's going to do the opposite. This one started from the bottom, so this one's going to start from the top. And then go down at the end. On the right side, it's going to go down just like the opposite of the positive leading coefficient. So this is what this graph is going to look something like this. And so let's describe what's happening with our math language. On the left side, that's the negative side. So as x goes to negative infinity, what is the graph doing? The graph is going up. The graph is going in the positive direction. So f of x is going towards positive infinity. So we did not get the same sign like we did up here. Now they are opposite. Okay. So on the left side, it's going up and up forever, so it's going to positive infinity. Now what's happening on the right side? Right side is the positive side, so where x is going to positive infinity, what is the graph doing? The graph on the right side is going down. That's the negative direction. That's going down forever. So the graph f of x is approaching negative infinity. Okay? And that is exactly how we do that. So your homework questions will ask you just to tell me if it's an even or odd degree. It'll ask you to tell me how many zeros there are, and it will ask you to tell me the end behavior. So I'll be looking for exactly these type of this type of stuff right now.